In this last segment, I want to explore some more complicated polar curves that we can explore with graphing utilities. So one way we can do this is we can enter polar curves in terms of a parametric equation. So what would be the parametric equations for this polar curve, where we have r equals sine of 8 theta over 5? Well, we know for the x equation, it'll be r cosine theta. So it'll be sine of 8 theta over 5 times cosine of theta. That'll give us the x-coordinate of our parametric curve. And then r sine theta for the y-coordinate. So it'd be r, again, sine of 8 theta over 5 times sine of theta. Okay. Now I'm going to switch over to GeoGebra, and that'll allow me to enter these parametric equations into a parametric curve, and we can see how this curve is traced out as the angle theta sweeps through some values. So as you see here in GeoGebra, I have those parametric curves entered. For x, I have sine of 8 theta over 5 cosine theta. Here I'm just entering t instead of theta. And then y equals sine of 8t over 5 times sine of t. So those are the parametric equations of the curve r equals sine of 8 theta over 5. Notice that for now it's set with the parameter range to go from 0 to 0. But I've put the right endpoint here on a slider. And that way we can observe how the curve is traced out as we increase that right endpoint parameter. Okay, so when I hit enter here, it's going to sweep through the values of theta. Okay, so we can see how this curve is traced out as the angle theta goes from 0, and it goes all the way up to about 10 pi. Okay. And that forms the complete curve. Okay, so we can see here that curve was traced out sort of in a spiral, a rotational spiral kind of formation. Let's watch it one more time. So there you can see how the curve is traced out using these parametric equations. Next, I want to investigate a family of polar curves who have the equation r equals 1 plus c sine theta. And in fact, we know one member of this family already, or actually probably a couple members. We know that, for instance, when c is equal to 0, then we just have r equals 1 as the circle of radius 1. And we also know that when c is equal to 1, we get 1 plus sine of theta, which is the cardioid. But let's look at what happens when we cycle through some various different values of c. And what I'll do is, again, I'll open this curve up in GeoGebra, and we can sweep through some different values of c to see what kind of curves are formed. Okay, so as you can see here, we've got the parametric equations for our family of polar curves, 1 plus c sine theta. Right now I have c set to 0, but what I'll do is I'll sweep through different values of c, and we can see how that affects the shape of our curve. Let's start with going in the positive direction. We know, for instance, now when we go to c equals 1, that gives us our cardioid that we graphed previously. But let's go a little bit further. Say we go maybe up to c equals 2. Well, notice here we get a similar shape, but now it's going to form that inner loop. And that inner loop is formed because now we've got 1 plus 2 sine theta, where sine of theta can now become negative, and hence we'll get negative values for r that form that inner loop. And of course we could go a little bit further out and we notice that the inner loop just increases. Let's go the other direction. So say we, and then by the way here, if I do values of c that are, say, between 0 and 1, notice that we still get a little dimple, but it becomes less pronounced as c gets closer to 0, where it's the circle. So now let's look at what happens when c is a negative value. Well, it's going to kind of form the same picture, but on the other side. See, when c is about 0.6, then we get sort of a dimple there that gets more pronounced as c gets more negative. Here at -1, it's still a cardioid, like it was when c is +1, but now it's oriented in the other direction. And then as c gets more and more negative, it's going to form that inner loop like we saw above. Okay, so there's for c equals -3, for instance. There we have this big inner loop that's formed when r takes negative values. Again, it can get very big and pronounced, but here it's interesting to observe how that inner loop is formed when c goes below -1, and then as c goes back to 0, it forms more closely to a circle. Okay, so that's the family of curves r equals 1 plus c sine theta.